have the talk about emerging energy management use cases for car charging. And in the beginning, it's getting dark. In the beginning, it's getting dark now in the Energy Linux Foundation Summit. Huh? Does it getting dark? Yeah. So you see here, click it. The moon is rising now. Oh, this is too quick. And the stars are twinkling. And now everyone falls asleep. And the wind is blowing. And the apex spot market price has fallen since midnight. So you ask yourself, should I get up now and charge my car? Okay, welcome everyone. It's me and Simon. We will present you this talk about the emerging use cases. And in the end, we hope that you find the answer if you should get up and charge the car. Okay. So Simon, it's your turn.
Yeah, hello from my side. So I will quickly talk about chargebyte, who we are. chargebyte is an 80-people company from Germany. We consider ourselves sort of a one-stop shop for charging equipment, like embedded systems, the brain for the charger. We have the end of line in Leipzig, but we have a couple of offices, 4 offices in Germany. One is in Vienna, one in the US. So quality made in Germany. This is the product line, but I don't go into that too much, just to get an overview. And for those who don't know how an EV charging setup looks like, you have a car, a rolling battery, you have a charger, and the charger consists mainly out of a controller with car communication and backend communication, and this comes from chargebyte in some cases. This looks like an advanced Raspberry Pi we've had. So this is what we do, and today, even though we are having different use cases, we have the home semi-public and public use case, high-performance chargers in the public usually, and in the home we have usually AC, but that's changing now, DC as well. And for some reason that we talk about later, we are now focusing on the home use case because chargebyte is quite active in there, and there's a special trend about vehicle to grid, vehicle to home, like having a DC coupled charger at home. And Ambibox. So this was recently announced that IAA, Volkswagen is working with Ambibox, which is our customer. So essentially Volkswagen is one of our indirect customers. So this becomes a big thing now. That's why I wanted to mention that. Back to Hauke for that.
So now is how it all started with open source. We think at first it starts with a company decision. You need to have open source implemented in your roadmap. So it takes decision, it takes time, and it's a strategic development. And what is defined as goals is provided to the teams. The teams work independent. They are self-aware and self-organized. And in this way, new dynamics and strong learnings are created. And with this open source, software development is also somehow special, that each member of the team has a special effect also on social aspects. So we had kind of project match pattern. We are charger controller manufacturer, so we need software which enables the charge controller to charge a car. This is the application layer of the controller. And we search for a modular framework, and it should fulfill our company strategy. It must match our vision and goals, and we want to learn from it. So it must not be perfect at the beginning. We want to participate in the process, and this initiative shall initiate a change in products and also in the teamwork. From the technical aspects, we have a modular framework, and by a modular framework you can tune it a bit to have different flexible solutions. So we can build different charging solution. And this is important for us because we are providing our hardware to different customers. So we must always have some flexibility. ISO 15118, this is the communication standard between the EVSE and the car. This needs to be inside, and OCPP as well. It has become a new standard recently from the IEC. And in this way, we share the maintenance efforts with a bigger community and enhance the overall quality. Maybe some short question: who has already developed software? In this audience, raise your hands. Okay. And at project start, if you deliver it to your customers, what do you think? Is it a lot of work to bug fix it and maybe gain some hands? Or do you think, yeah, exactly. So it's this work with a team, it can hinder them to develop essential new function which you desperately need. And that's a problem if you don't work with open source. So more hands on the code, also more big bug fixing in the community. With EVerest, which is part of this Linux Foundation Energy, we found a project which fully integrates with our strategic developments. It has a visual impact on our social environment. So if we save energy, if we use renewables, we save the environment. It puts the people in the position to create software with impact, and you have a bit hands-free for innovations because of this lesser maintenance work. Sometimes it feels like we are still sitting in the school bus, learning from each other, and here you see there are still free seats, so you can still join. Okay, are the wall boxes part of the energy system? The answer is yes. More precisely, a part of the energy transformation, because it's a huge energy demand we have with the cars on the grid, and also the fossil fuels can be partly replaced by renewable energies. And we think what people want is to make individual driving more sustainable, and this sustainability is also a goal from the Linux Foundation Energy. Okay. So let's take a closer look to this renewable energy segment. First, starting with solar. Yeah, and this has become the best affordable energy resource recently. And if you take into account that this is a volatile energy, it's even more interesting that it can be so important. These volatile energies also cause negative spot market prices, and they reach in Germany, these are numbers from Germany, more than 450 hours until now, okay? And the next thing, in Germany was already a leading country for solar energy production. We saw a talk here from the Netherlands. They have big problems with the grid now, using the electric vehicles. In Germany, I think there was always a good grid with less risk on it. So it was possible to place a lot of solar energy. And by today, in this year, we produced nearly 18% out of solar energy. So it's already much solar in the grid. But now, if you continue, it has still doubled in 5 years. So from 2020 to 2025, the solar power capacity installation have doubled. And in Europe, they have also doubled within 3 years, so also very quickly. And worldwide, it has even doubled in the last 2 years. So there's no way around this volatile energy. We need them. It's cheap. It's environment friendly. And we are now searching four solutions, and one are these storages, and the batteries are not only produced for storages, but mostly produced for mobile batteries. It was Adele Sau in a Smarter podcast who said that it is about 780 gigawatts produced in 2024 was for the electric vehicle segment, and this is 2/3. And now to see how this can be used, these mobile batteries, we are also part of a project in BFlex Industry. We're trying to use these flexibilities of large company fleets. And yeah, we all know that this controlled bidirectional charging becomes necessary from the system and from the grid view. Okay, thank you.
Okay, so chargebyte adopted EVerest, and to my knowledge, chargebyte is the only controller manufacturer that implemented and scaled EVerest. So we have a couple of thousands of installations running EVerest in production. But we were missing something because we were talking about this dynamic charging. So we made an internal assessment in chargebyte, just what our colleagues thought what might be important. And this is solar charging. First, electric cars is the one of the most important ways to store renewable energy, dynamic tariffs, and PD charging. And that's why we had to integrate sort of mechanics into our chargers, or at least we thought it might make sense if we can deliver something along EVerest. And then we added another open source. The vision from that is bring energy management functionality with the charger, because external energy management systems are fine, but you need an installer, they cost something, and essentially at the end it's software, so why not install it on the charger itself? At least basic functions you can deliver with the charger. And yeah, it has to be frictionless user experience, modern app, everything that we know of energy management systems today. It needs to support solar and dynamic tariffs for sure, and it needs to be supporting the foundational idea of the energy transition. And with this vision, we introduced a new software along EVerest that runs on our controllers, but it can run everywhere. You can install it on the Raspberry. This is an IoT service called Nymea. I had a company in that field called Nymea for 10 years, essentially, and we brought it into the chargebyte. And what we did with that, we made CB Energy out of it, and I want to give you a quick demo with that. Just have to, does this work now? Yeah. So this is a user interface for a charger. The server side runs on the controller. So there is no cloud. You can use a cloud for remote access, but yeah, as you see on the very top, I will just quickly go through it because it makes the whole system understandable. You can choose between different charging points. You can register a set of cars. You need it because you need some context. So how much energy do I deal with? How much energy capacity do I have? And all that stuff. Then we have some sort of a tab to choose between quick and eco charging. I will come to that later. In the quick charging menu, we can manually choose between the phases if we are on AC. In the eco, you can activate a target time, like when do we want the car to be charged at what SOC level. We'll also come to that a little bit later. And foundationally, we have 3 tabs. So this is the charge point view, which represents your charger. But the most interesting part is integrating it into your renewable energy system. This might be your solar system at home. So what the system does, it connects itself locally to an inverter, and the inverter knows everything like the production, the consumption, the state of charge of your stationary battery if you have some. So that's the first data point sort of we connected. The second one is actually a more easy one, is dynamic tariffs or any kind of weighting API that we might use. And with that, when we turn into the eco mode and we plug in a car, just adding a new window here. So then the system starts charging, and now we are charging 9.6 kilowatts because we are producing 9.7. So we have a little bit of home consumption. And also, just that you have seen it, there is this energy dashboard that you're used from any other solar app. Because we also collect the same information, we can show them. We don't really use them now for any smart algorithms. Now we are only live reacting to it, but the goal is to have more advanced algorithms for other use. Thanks. For other algorithms too. So that's open source. That's something we want to bring into the Linux Foundation Energy. We didn't do it yet. Maybe if you want to try it, this is you can just download the app and have a demo mode if somebody wants to take a picture. 3, 2, 1. Everybody can try this solution. I think this is your slide, right?
Okay. Yeah, this is only explaining again that we brought these two stacks now together. Both is open source. The Nymea is an IoT stack where we're very flexible. We can make good products out of it in the end. And Linux Foundation Energy EVerest, you heard about it. So on our Linux chargers, we are able to put the system, and we extensively use it for testing, for example, from the Charin tests with EV and manufacturers of cars. We're testing against them this early development states. For example, last year, the plug-in charge was already some years ago, and nowadays it's ISO 15118-20, bringing bidirectional charging into play. Oh, then we are already at the last slide. So this is basically the different use cases where we are finding solutions with products and with open source contributions. So for solar charging, it started very early because it's very effective. The owners from houses who have the possibility to install PV, it's possible for some to basically charge their car for half a year for free if they have the according driving profiles. So it's very efficient. And then the dynamic tariffs reached us. So it was Tibber and Octopus, where it's possible to charge, for example, at night very cheap for 5 cents per kilowatt hour into the car. And then, of course, electric driving gets very, very cheap compared to the gas engines. Then we have now and next year, as we mentioned already, first DC charging solution come up with bidirectional charging capacity. This is possible for vehicle to a home. I mean, there might be also contracts to energy providers, with energy providers, where you might not feed your house, but they control the charging of the car and give you money for that. That could be also possible. But there's also technology where you can store the solar in your battery from the car and then feed back to the house. For AC, it's a bit difficult. So maybe I wrote here 2029, because for AC, the car manufacturers have to qualify their onboard charger for being able to feed back to the grid or feed back to the house. And so this takes some time. The ISO 15118-20 was released for DC charging right now. Technology is ready, and there's an amendment for AC, which we are still waiting for. Yeah.
What you just understand, so the charger, it either provides Sorry. I'm going to start again. So just to make sure I understand, so the charger either provides electricity in DC or AC to the car. But so what makes it complicated to send it back AC or DC to the charger? Why? Because afterwards in the house system, it's the same type of current, no?
This roadmap sort of represents what the market roadmap, not the chargebyte roadmap. So DC PD charging already works, but it's AC coupled towards the grid. So you have your 230, 400 volt system, you add a small DC charger, you have a DC coupling to the car. The car can give DC, of course, from the battery, it gives DC back to the charger, and the charger inverts it back to 230, 400 volts. And this is connected to the grid. And I believe that bidirectional AC charging, it exists, but it will never hit the mass market because it's super hard to essentially build a car that has global grid code compatibility. So I think if PD happens, then it's always DC coupled from the car's perspective. From the charger perspective, this is now AC usually, but I think also we will see something like DC microgrids in the future. But today, and this works already. BMW just announced it. BMW has a €2,000 BMW Pro wall box, which is a small DC wall box. It can do PD, and it works with E.ON tariff. BYD and Octopus Energy released it a couple of weeks ago in the UK. I think Volkswagen has their own tariff with Elli, and actually Ambibox product. So it's existing already today, and I think we are now in the startup phase of ramping, or in the starting phase of ramping it up. I guess in 3 to 4 years we will see. So now a DC wall box PD is a price range of a premium AC wall box, but I guess in 3 to 4 years it will be in the price range of, solar micro inverters, and then technology will be cheap and something like this will be much easier. Then it's more about the marketplace. Technology is already there. So this is more the market side. I think it's faster than that actually, because this year is quite interesting already what happens. Okay, and so the main reason why we are here is what you need for DC charging and energy management is this software solution that we are presented, and basically we wanted to ask if somebody has interest in collaborating on something like this. It's an energy management software that can be used inside a charger, outside a charger, whatever. We have some companies and customers that build standalone energy management systems, but yeah, straight to the point. We would like to invite you to collaborate, or at least try it, give some feedback. It's a productive system. There's a lot of effort in it. It runs on a couple of thousands of installations, but we would like now to open source it and create something like EVerest for the industry, because we don't see something like industry standard in the energy management sector. There's a lot of commercial stuff, but there is not the open source project yet, and maybe it has a good chance. I think that's it. I will leave that slide now.
Okay, but there's a thank you slide.
We need the thank you slide.
So thank you very much for your attention and being here. It was a pleasure to talk with you, and we are open for your questions.
Yep, thanks.
Should we have one microphone?
I have actually two questions. One about protocols and interoperability. One about more architectural responsibilities of the software you presented. So let's start with protocols. Communication between the solar panel and this energy manager. How would that? How do you realize that?
So this is a system that runs in the local network, and it connects locally to the interface of an inverter. Oh, no, this is the wrong one. So basically we implemented, I think it's about 10 inverter and much inverters. There's much more than that, but for example, SMA native integration locally, coastal,
Okay.
and all that. So we did it natively because A, it doesn't cost you anything, and B, the resolution of the data is much better than any cloud-based thing. Plus,
Yeah.
you don't have out like
So, but these are the proprietary protocols of the manufacturers
yes,
that you
actually
need
yes.
to implement.
So that's the crucial part of the software is this middleware that translates between the vendor API or
Yeah,
protocol.
and that's all implemented in Nymea.
Yes, exactly.
Here also has a plugin section, and so without knowing the rest of the application, you can start to create a connection to a new device.
Yeah. Okay. That's interesting. I think there's an alternative approach when you use a standard interface between device and EMS. So we'd love to talk more about that with you. And then the optimization, is it also happening in Nymea, and what kind of algorithms are running there, or is it running somewhere else?
So the middleware Nymea has different sorts of plugins, like you can add modules to integrate with something, but there is also what we call experience plugin where you can inject business logic. So it's more or less an encapsulated base of code where you can define the business logic and it accesses the middleware, and it's running in Nymea, so it's running in the same daemon. It can be C++ or JavaScript, and yes, this is part. I think this is not the most complex part of our solution because we only do solar charging and dynamic pricing. I mean, it sounds easy. Still, there are thousands of edge cases. But yes, this is part of this solution and runs also locally along the middleware, sort of.
Yeah. Yeah. Thanks.
But this is highly customizable too. So I think what we did, the first use case was solar charging. We learned a lot about that, and we added the grid tariffs. And let's see what the future brings.
Thank you for the talk. Earlier you mentioned a different kind of use case that was domestic versus semi-public, public. And I would like to hear about maybe plans to doing this about, beyond the domestic case and maybe for small medium enterprises that have a range of chargers, or larger houses, as the photo showed, that you in the garage have a range of chargers, and looking at it just with larger installations.
Yes. So that's the next step that we want to go. The technology-wise, everything is there. We can register as many chargers as we want and as many cars as we want. It's more or less only upgrade of the UI layer. So the operator, let's say it's a company and they have 20 stations and they have 50 cars or something, have a different kind of access to the system. And also what we need in the business logic part is to upgrade it a little bit to have a more standard load balancing algorithm. It should still consider solar and grid tariffs, but overall it is more about balancing the load and when do they have to leave and stuff. So yes, we are planning in expanding it into semi-public space. I will call it like that. It's not yet there. It was created out of the residential space, and now we are evolving from there step by step.
Yeah, thanks. Oh. I have one small question. That is Nymea depending on EVerest as a lower layer, or is?
No, it's a completely what is the word? Self-sustained. No, it's its own stack, its own daemon. It runs along every other application that runs on the controller or wherever it runs. It just connects to EVerest using an API. And EVerest behaves like a normal charger. I mean, the system understands any kind of charger, and EVerest internally is just representing another charger for the system. So the stacks can run anywhere. The Nymea stack can run on a Raspberry and also connect from the outside to a charger. But we find it very intriguing to have this functionality shipped with a charger already, because then there is one less thing to consider for an installer.
Yeah.
Sorry, so I had arrived a bit later at this presentation, so I didn't follow the entire... I mean, I'm not sure I fully grasped Nymea. To make sure, Nymea, is it only focused on electric charging of cars, or is the scope bigger as a home energy management system? Just to make sure I got that one.
Yeah, this is historically, we founded the Nymea stack in 2013 in the smart home sector. So back then there was no Alexa and Google Cloud and all that stuff. It was founded in the context of a university project, and it was funded by the government. And then 2016, we sort of made an IoT framework for digital products. So there was the IoT bubble back then, and we used the stack to digitize products because everybody needed to sort of have Wi-Fi enabled and some sort of smartphone app. And like from the business perspective, it wasn't the most fruitful way, to be honest. So we iterated towards energy management. There we found a space where there's a true problem, and we could make we can generate a true value with that. So the IoT framework Nymea is actually very generic. You can do smart home stuff, smart energy stuff, whatever. But we found, like in the energy management sector, to be, as I said, it generates the most value there.
And so IoT means Internet of Things, and you can really think that one charging station is a thing in this generic framework, and then with the view on this thing, you get out the different data and make it visible for the user, make it controllable, make it accessible. And also an aim is this is frictionless usability. So it's very easy to add a charging station to this app. So we install it at home, and then basically it's already possible to search for this charging station and to add it to the user interface. And this was one goal for the design, to make it very easy accessible, because other home management systems, you know, that they are quite, they need to be configured, and it's quite knowledge necessary to do that. And we want to build something for the end user. And earlier it was outside from chargebyte, and then before 2.5 years, the Nymea company became chargebyte, and so then the charging topic emerged more extensive. So then we had a stronger focus on this, to plan when you are leaving and to plan the state of charge, and now to add more charges to it, to do load balancing. So this came with the integration of Nymea to chargebyte.
The story behind it is, we as an individual startup company, we made an energy management device with the software, and we deployed it. And we had we had close to 1,000 installations already. And we had made experience, a lot of support, and so we could shape the product with the market. But then we saw, okay, scaling this into 100,000 is super hard. Either you go the venture case and you drag in a lot of money and you make a B2C product, or you hook up with somebody. And our idea was, because that's the differentiator, to ship this software with an energy asset like a charger or a heat pump, whatever. And from this idea, we were looking for a good partner, and we found it at chargebyte. So that was the story behind it.
I'm thinking of there's so many companies developing their own proprietary solution and energy management solution, and I guess they rely on Nymea.
Yeah, I will just repeat it for the stream or for the recording. There are a lot of companies working or copying the same thing over and over again. And yes, that's why I think it's like the EVerest value proposition. It's actually commodity. Nobody needs to reinvent the wheel in that aspect. And it could be something where working together might make more sense. I'm actually quite sure about it, yeah.
Okay, So I guess there are no more questions.
Yeah. Thanks for your interest. Enjoy the lunch.